For the longest time, we've thought of AI as this super smart analyst, right? It labels your photos, it translates text. But what if an AI could be an artist? What if it could create something totally new, something that's never existed before, completely on its own? Well, that's the wild idea behind a groundbreaking 2014 paper on what are called generative adversarial networks, or GANs. And we're going to break it all down. So, let's kick things off with a challenge for you. Imagine a machine studies thousands and thousands of handwritten numbers. Do you think it could then create a brand new one? I'm not talking about just copying one it's seen. I mean a completely original digit that looks like you or I could have written it. What do you think? And the answer? A resounding yes. Take a look. Every single digit here, except for that column on the far right, was dreamed up by an AI. And that last column? That's the crucial piece of evidence. It shows the closest real digit from its training data. See how they're not identical? That's how we know it's not just a fancy copy machine. It's actually learning the idea of a number and then drawing its own. So how on earth did they do this? The secret wasn't just some insanely complex math. Nope, it was a brilliantly simple and powerful analogy that just made everything click into place. And here it is, the big idea, straight from the source. They imagined a game, a rivalry between two AIs. One AI is a counterfeiter, trying to print perfect fake money. The other AI is the cop, whose only job is to spot the fakes. This simple concept, this game of cat and mouse, is the key to this whole thing. All right, let's meet our two main characters. On one side, we have the generator, that's our counterfeiter, and on the other, the discriminator, our cop. They have completely opposite goals, and it's in their rivalry that the magic really happens. The generator's mission is pretty straightforward. It starts with just random static, basically a blank canvas. And its job is to turn that static into something that looks so real, like a perfect counterfeit bill, that it can fool the cop. That's its only goal. And then you've got the discriminator, our cop. This one's the expert. It gets to see both the real stuff and the generator's forgeries. Its only job is to make a call, real or fake. It's the ultimate critic in this whole operation. So you've got these two rivals. How does this competition actually work to create something amazing? Well, it's not just a one-time thing. It's a relentless training cycle where each one forces the other to get smarter. Let's walk through how it unfolds. The paper calls it a Minimax two-player game, which is just a fancy way of saying it's a zero-sum game. If the discriminator spots a fake, the generator loses that round. But if the generator successfully fools the discriminator, the cop loses. It's a constant battle where one's win is the other's failure. So the process is this endless loop. The generator makes a batch of fakes, the discriminator looks at them alongside some real examples and makes its call. Then they both get a score. The discriminator finds out how accurate it was, and the generator learns what it did that got it caught. Then they'd both take that feedback, adjust their strategy, and get ready for the next round. This shows that dynamic perfectly. In the beginning, the generator is terrible and the cop can spot the fakes a mile away. But the cop's feedback tells the generator how to get better. So the counterfeiter improves. Now, the better fakes force the cop to get smarter. This back and forth continues, round after round, until the generator's fakes are so ridiculously good that the cop is basically just flipping a coin. It can only guess with 50-50 accuracy. At that point, you know the generator has created a masterpiece. Okay, so the theory sounds cool. But what did this whole cat and mouse game actually produce? Let's look at the results that really shook up the world of AI. And here are those generated digits again. What's so incredible is how sharp they are. They're not fuzzy or ambiguous. They have clear, distinct styles, almost like different people's handwriting. For AI-generated images at the time, this was a massive leap forward. So, after mastering numbers, they decided to up the ante with a much harder dataset, photos of real-world objects. Now, these results are definitely blurrier, but you can absolutely make out the shapes of horses, cars, and airplanes. This proved the system wasn't a one-trick pony. It could start to learn the essence of complex, real-world images. And this right here is probably the most important sentence in the whole paper. I really want to emphasize this. The network isn't just creating a collage of images it's seen before. It is developing a genuine, abstract understanding of what makes a horse, or what makes a 3, and it's using that understanding to create something new. Now this is where it gets really mind-bending. What you're seeing here is the researchers exploring the AI's imagination. As they smoothly tweak the random noise they feed the generator, the image seamlessly transforms from a 1 into a 5. This proves the AI hasn't just learned what a 1 and a 5 look like in isolation. It's learned the space in between. It's built a coherent map of numbers. So why was this such a game changer? Well, this table says it all. The old methods for generating images were computationally expensive, slow, and often produced really blurry, unsatisfying results. Adversarial nets, on the other hand, were way simpler to implement. They trained using standard tools everyone already knew, and the results? Well, they were incredibly sharp. Okay, so we've seen the results, but why did this one paper kickstart a whole revolution in creative AI? What was the secret sauce? The advantages for researchers were just enormous. All of a sudden, you didn't need these slow, complicated statistical methods anymore. You could train these incredibly powerful generative models using the same basic tools, like backpropagation, that were already powering the rest of the deep learning field. It just made everything so much more accessible and flexible. And here's another really clever part of the setup. Think about it. The generator, the artist, never actually gets to see a single real image, not one. It only learns by listening to the feedback from its critic, the discriminator. This forces it to build its own internal understanding of the world, rather than just becoming a great forger. And the authors, they knew they were onto something huge. They wrapped up their paper by outlining a future where you could tell an AI what to create, create a picture of a cat, and where this whole adversarial idea could be used to improve all sorts of other machine learning tasks. And boy, were they right. Which brings us to one last really big question. This adversarial framework essentially taught a machine how to imagine. It took AI from being just an analyst and turned it into a potential creative partner. And as these systems get more and more powerful, it forces us to ask, if a machine can create work that's new, that's coherent, maybe even beautiful, what does that say about the nature of creativity itself?